remember with this, NCR has like the n minus r factorial. NPR does not. Also, please remember that NCR is the same as NR, if they write it like that. Also, if I had 6C3, that's not a good one to do. If I have 16C3, what's that the same as? 16C something else other than 3. 13. The common difference between the two. All right. How many arrangements of the letters of the word reason are there if arrangements must start with an S? Now, if it has the word arrangement, it's a permutation. If it's a word, it's a permutation. So this is guaranteed to be a permutation, okay? Now, what do we have to check off with words? We have to make sure that there's no doubling or tripling letters. If there is, we have to divide by them. Reason doesn't have any. I always write the word out. Reason 1, 2, 3, 4, 5, 6. It must start with an S. How many S's? 1. And then 5, 4, 3, 2, 1. Which is the same as 5 factorial, or 120. The next one, in all of the letters in the word diploma, if all of the letters in the word diploma are used, then how many different arrangements are possible that begin and end with I, O, or A? Diploma, does it have any doubling or tripling letters? No. How many letters does it have? Make sure you double, triple, count. Some people will be like, it has 6. No, it doesn't. Count them. So 1, 2, 3, 4, 5, 6, 7. It has to begin with an I, O, or an A, which is 3. What do we assume when it's a word? You don't repeat. You have what you have. So I'm going to keep the A here. Whenever I don't repeat, I keep something. I, O, so 2. And then I would have all the rest left. So 5, 4, 3, 2, 1, which is actually the same as 6 factorial. Why? 3 times 2 is 6. 5, 4, 3, 2, 1, so 720. Josh wants to rent a car. He narrowed his choices to a sedan, a compact, or an economy car. The colors available are black, red, or white. He may choose between a standard or an automatic. Determine the number of outcomes. Oh, there's 3 in the middle. Okay. Now, oh, that would have not been good. So 18. Now, how they can make this question harder is they can say, okay, let's change it to a totally different question. You have 5 breakfasts, 6 dinners, and what else? 24 snacks, sure. Now, to make you through the day, you get to pick 1 breakfast and 1 dinner and 6 snacks. How would we do the question? You have 1 breakfast and you choose 5. That makes no sense. So 5C1. And then we have 6C1. And then we have 24C6. And what do we do with them? So you want a breakfast or a dinner or snacks? Multiply them because it's and. Okay, so the difference in if we actually pick more than 1. Okay? All right, you're going to do the next one. Okay, a car purchaser has a choice of 2 upholstery materials and 4 colors. How many choices are there? 8. If you're given something like this on the diploma, you should feel like getting up and doing some cartwheels. I don't think it's going to happen. However, options there. Okay. We have the word Edmonton. Shh. What's the catch with the word Edmonton? Two O's and 2 N's. So if we just do the word Edmonton, what are we going to get? 1, 2, 3, 8 factorial divided by 2 factorial, 2 factorial. And that would be our answer. Now, what if I say, how many ways can we rearrange Edmonton so that it starts with, no, so that the vowels are together? The vowels are together. 2, 3, 4, 5, 6, 7, 8. Y's never count. Okay, how many vowels are there? How many vowels? No, there are 3. And there's an N and E. No, you have to count them all. There's 3. Okay, so remember what I said to you guys? You have to count all of them as different letters, and how do you deal with the fact they're actually the same? Divide by the factorial. So we're going to start with the vowels. So we have 3, 2, 1 vowels. How many left? 5, 4, 3, 2, 1. And we're going to divide by 2 factorial in brackets. However, yes, because I said has to, if I said start with vowels, this would be the answer. But I said the vowels have to be together. So there's actually 6 more places I can move them. 1 here, 2, 3, 4, 5, 6. So I'm actually getting 3 factorial, 6 factorial over 2 factorial, 2 factorial. So I get people who do this correct, and then they get the answer wrong. Not a chance. Now, if I type this into my calculator just the way it is, if we type it in like this, what's the problem? If we type it in like this, what's the problem? It needs brackets. If you type it in like this, you're going to get an answer, of which it's probably going to be on the diploma, because that's what I would put as an answer, because that's what you're going to make mistakes. So when you type this into your calculator, make sure you put in brackets. Now 6, what do we have to do? If you type it into your calculator, it's going to say no thank you. But you can expand it out. 95 times 94 times 93. Shh. Remember, you need to expand the bigger one to be the smaller one. These cancel off, and then it's just 95 times 94, which your calculator will allow to happen. What's 95 times 94? Okay. Then this one, a lot of these have came up before. We're just repeating to remind you. So it says, determine the number of different arrangements using all the letters in the word accesses. So A, C, C, E, S, S, E, S. Whole bunch of doubling and tripling letters. So it has to begin with exactly 2 S's. Exactly 2 S's. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Before I even do the question, I'm going to put 2 factorial, 2 factorial, 3 factorial in brackets in the bottom. Because no matter what I do, I'm going to need that. Now, begin with exactly 2 S's means the first 2 need to be S's, but what? The third one can't. So I have S, S, no S. So I have 3 options, 2 options. How many are not S's? 5. Then how many do I have left? 5, 4, 3, 2, 1. And when you do that, what do you get for an answer? It should be small. 150? It's not 180. Now, begin with at least 2 S's means you need 2 cases. You need to begin with 2 S's, which is 150. This is 2 S's. Or, addition, 3 S's. 1, 2, 3, 4, 5, 6, 7, 8 divided by 3 factorial, 2 factorial, 2 factorial. And we're going to have 3, 2, 1 to begin with our three S's, SSS. And then 5, 4, 3, 2, 1, which I think is 30. 150 plus 30 is 180. Why are these answers different? Because some has to begin with exactly 2, and that one could be 2 or 3. 8. At a car dealership, the manager wants to line up 10 cars of the same model. Keyword word here is same model. So if you get the same model, or you're looking at things that are identical, we have to remember to divide by factorial. So same model in a parking lot. There are 3 red cars, 2 blue cars, 5 green cars. If all 10 cars are lined in a row facing forward, determine the number of possible arrangements if the blue cars cannot be together. So when it says cannot be together, we do total, no restrictions, minus the blue together. Why does that work? I've given you guys reasons of this before. If I asked you how many people are in this school but not in this class, you wouldn't go count all the people who are not in this class. You'd say, hey, Mrs. O, how many people are in this school? And you'd be like, hey, Mrs. Lepp, how many people are in this class? And you'd subtract them, and what would be left over are the people not in this class. So we're going to do the same thing here. Total, no restrictions. 10 factorial. If these were different models of cars, it would be 10 factorial. But because they're the same model, the 3 red cars switched around make no difference. So we'd have 3 factorial, 2 factorial, 5 factorial. That's total, no restrictions. So that's the absolute most number of ways that I can rearrange these cars that would look different. So what's 10 factorial divided by 3 factorial, 2 factorial, 5? So substantially smaller than 10 factorial because it takes away all those cases where they would look the same if I rearrange them. Then you have to put the blue together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 3 factorial, 2 factorial, 5 factorial. Blue together. How many blues are there? 2. So I'm going to hook them together. I'm going to get 2 then 1. Yes, I know that there really isn't 2 then 1. If I put them, they're going to count out. But I don't care. I treat them like they're completely different and then just divide by the factorials to get rid of those double F's. Then I have 8 cars left. 7, 6, 5, 4, 3, 2, 1. And what do I have to do? Multiply by 9 because they could be here or here, here. I multiply by 9. So what's 9 factorial times 2 factorial divided by 3 factorial? 504. So when I subtract them, what do I get? $504. 16, did you say? I thought you said 2,560, and I was, that wasn't even my biggest issue. It was the 60 that I thought was really weird. 2016. All right, flip over. Try these out. A volleyball team made up of 6 players stands in a line facing the camera for a picture. If Joan and Emily must be together, then how many different arrangements are possible for the picture? 1, 2, 3, 4, 5, 6. Joan and Emily must be together. So 2, then 1, 4, 3, 2, 1. And I have to multiply by 5, so 240. How many paths going down and to the right are there from point A to point B? Remember, we went D, 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 R, 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 der. So if we had the word der, we would rearrange it so that we had 4 Ds and then 5 Rs, right? So on the top, we'd have 9 factorial for all of the letters. But on the bottom, we take away, we divide by 4 factorial, 5 factorial for the fact that they're all the same, the D's and the R's. So what is our answer? 126? Thank you. Okay, Explain why n must be greater than or equal to r in the formula NPR. Why does n have to be greater than or equal to r? Yeah, you can't choose more than you have. Okay. So if you're given anything like 12 and 13, you're going to have to expand them out by putting them into the formula. So NP2 is the same as n factorial over n minus 2 factorial equals 56. Remember that n has to be positive, right? You can't have a number factorial because that's negative or 0, because it counts from that number decreasing by 1 all the way to 1. So we take the largest one and expand it, which is n. So n minus 1, n minus 2 factorial, which is where I'm going to stop because it's going to cancel off the bottom. N minus 2 factorials cancel, and I'm left with n times n minus 1 equals 56. Expand it out. N squared minus n equals 56. Please don't tell me it's 0 and 1 at that point, and just ignore the factors of 56. That's not helpful. So we expand it out, we get n squared minus n equals 56. It's a quadratic, so we have to move everything to one side. What multiplies to give me negative 56 and adds to give me negative 1? Negative 8 and positive 7. So we get n equals 8 and n equals negative 7, which makes absolutely no sense. So the answer is 8. You can't do negative 7 factorial when you plug it back in. It's not going to work. You also can't say negative 7p2. It's not possible. Okay, then we have to solve a bigger one at the bottom. So we're going to do np3, which is n factorial over n minus 3 factorial equals 5 over 1 times, it's a multiplication symbol, n minus 1 factorial over n minus 1 minus 2 factorial. This isn't a problem. I'm just going to show you something up here for a second. If I instead had np n minus 2, let's say, like that, I want you to go fill that into a formula. When your r is a binomial, you have to remember to subtract the whole binomial. So this would be n factorial over n minus 2 factorial. However, I'm subtracting a binomial, am I not? So I would have to remember to minus n minus 2, which actually gets me minus n plus 2. You have to remember that when you have a binomial in your r, that you have to subtract the whole binomial. Put it in brackets. It's not in this question, I'm just showing it just in case. So I have n factorial over n minus 3 factorial equals 5 times n minus 1 factorial over n minus 3 factorial. Instead of expanding those all out like crazy, if we know that this denominator is n minus 3 factorial and we know the other denominator is n minus 3 factorial, what can we say? That the numerators must be equal. So if this is the same as this, then this must equal that. So we have n factorial equals 5 n minus 1 factorial. When we have factorials, we need to get them together so that we can cross them off, right? So what am I going to do next? Dividing by 5 isn't going to get any n's near it. Divide by the n minus 1. Then I can expand my n factorial out to n minus 1 factorial over n minus 1 factorial equals 5, and then life just got easy. Done. We're going to flip over and work together with them. So the next one says, if 14 different types of fruit are available, how many different fruit salads can be made using exactly 5 types of fruit? 14 fruits, 5 fruits. Is it a perm or a com when you're making a fruit salad? It's a com. It's not a perm because the order in which you pick the fruit doesn't make the fruit salad any different. You're throwing it all into one bowl, right? Just like that example where we picked books from a library 3 at a time. We took all 3 books, you put them in your backpack. The order doesn't matter. You get to take them home or you don't. The 5 fruits you pick here, they're either in the fruit salad or they're not. So it's a combination. So would 14 factorial cover that? No, it makes no sense. So they want the correct solution is which students? Ron suggested 14P5. Does that make sense? No, it's a perm. Michelle solved and said 14C9. Would that work? Yeah, because it's the same as 14C5 when you take the fraction. Student 4 is just lost in so many ways. First off, they put the 5 first. Second off, they picked a P. There's so many problems with poor Jackie. Jackie is just having a rough time. And then 14.5 is good. 14.9 would be also good. So student 5 Stan's good too. So Michelle and Stan. The next one says, at a meeting, every person shakes with every other person exactly once. If there are 36 handshakes in total, how many people were at the meeting? So we don't know N. We have to decide, is it a P or a C? Does the order in which 2 people shake hands matter? No. So it's a C, you were right. And how many people shake hands at a time? 2, 3, or more is awkward. And it equals the total, which is 36. So we could fill it into our formula, or we could do what? Guess and check. It's a C. Combing your hair order does not matter. Oh, bless you. C is a com. Order doesn't matter. So what do you get? So 9 people. This is one of those perm-com mixes. So in how many different 4-letter arrangements? So it says arrangements and it's words. So we're in the end, we're going to have a permutation no matter what because we're taking letters and arranging them. Are possible using 2 letters from smile. So I need 2 from here. And 2 letters from frog. So I need 2 from there. How can I get the letters from those words? Yeah. So this can be 5C2 and then 4C2 because I'm not ordering them. I'm just getting 2 letters from each. So what's the problem now? You haven't arranged them. So I have 2 letters, another 2 letters, I have 4 letters. I now need to arrange them. So 4, 3, 2, 1. And what do we get for an answer? 5C2 times 4C2 times 24. 4 times 3 times 2 times 1440. Okay. Now binom theorem. So remember with binom theorem, it has to be x plus y to the n. Remember, the total number of terms is what? If I'm looking for term 7, let's say, what does k equal? Because it's always 1 less. Because term 1 starts with k equal to 0, and you go all the way to k equals n. So that's why there's always 1 more term than n. Because you start off at k equals 0, and you go to k equals n, which gets you 1 more term. Okay? So this one says, find the value of a if this expansion has 18 terms. So what are they just telling you that n equals? 17. It's always 1 less, correct? So all I do is I go 2a minus 5 must equal 17. Add the 5. 2a must equal 22. So a must equal 11. Okay, a student made the following statements regarding the expansion of a plus b to the 4. The total number of terms is 5. Is that true? Yeah. N plus 1. So 4 plus 1. So 5. Yeah. The middle term. If we don't know what the middle term is, we can still go term 1, term 2, term 3, term 4, term 5. The middle term is term 3. What does k equal then? K equals 2. It's always one less. Term 1, k equals 0. Term 2, k equals 1. Term 3, k equals 0. So let's, or k equals 2. So we're going to do, to find this one, we're going to go 4c2 a to the n minus k, oops, b to the k. It's just off your formula sheet. What's 4c2? We got 4 from n, right here. N, x, y. You get 6. A squared, b squared. Hey. The sum of leading coefficients is 14. You'd have to expand it all out and check that. So I'm going to do that last because I don't feel like doing that right now. For the term 4a cubed bm, the value of m is 1. So if it's a cubed, we're going to have a to the 4 minus blank. When we don't know what a k is, we just put blanks, right? B to the blank, 4c blank. I need it to be a cubed. So blank is going to be 1. 4c1 is 4, a cubed b1. Is it true? Yes. The leading coefficient of the first term is 4c1. Is that true? You don't need to do anymore, but proving it. Is the first leading coefficient of the first term 4c? No, it's 4c0. But remember, it only is 4c0 because both a and b don't have coefficients. If a and b had numbers in front, you'd have to expand those out and then multiply them, and that would get you the leading coefficient. Okay? And then when you expand them all out, 14 isn't the sum. So it's going to be 1, 2, 4. This one wants us to determine the simplified form of the sixth term. What are they asking us to find? K equals 5. We know this is x. We know this is y. We know this is n, and there's a plus sign between them. Y actually is the negative 2b. I don't know why I put an a. That's an x. Sorry. So we fill it into this formula. We're going to get 7c5 x, which is a, to the 7 minus 5, and then y, which is negative 2b, to the 5. What's 7c5? (21). A to the 2, and then what do we have to remember to do on the last one? We have to put the 5 to both the negative 2 and the b. If you are doing any negatives to an exponent, please put that down. Any negatives to an exponent, you're going to do that value in brackets to the 5. So negative 2 to the 5 is actually negative. What is it? 32? 32 b to the 5. And then we have to remember to multiply the 32 and the 21. What do you get? Oh, yeah, it's negative 32. It's negative, sorry? Okay, this one. In the expansion of 3ab squared to the 10, 3a is x plus b squared is y to the 10 n. What is the coefficient of the term containing a4b12? So do we know what term we're looking for? No. When we don't know what term we're looking for, we don't know what k is. So we leave blanks for k. So we're going to try it out. We're going to do 10c blank, 3a to the 10 minus blank, b squared to the blank. How do I know what to put into the blank? Yeah, you can either say, hey, I need B to be 12, so the blank needs to be 6, or hey, I need A to be 4, so the blank needs to be 6. Either way, the blank is 6, so K is 6. So what term are we actually finding? We're actually finding term 7. Sometimes they might just ask you what term you're finding. This one, they want the coefficient, so they want the number in front. What's 10C6? 210? And then this is to the 4. 3 to the 4 is 81. A to the 4. B to the 12. What's 210 times 81? A4, B12. So what is the coefficient? 17,010. Okay, this one comes up often too. Determine the constant term. What's the constant term mean? Term without a variable. So we don't know what K is again, but we do know what X is. We know what Y is. We know what N is. So let's fill in what we do know. So it's going to be 6C blank, X squared to the 6 minus blank, 2 over X to the blank. So I need them to cancel. The one on the top is X squared. It's going to need a smaller number to make the bottom be the same as it. So if I try to 5, this would be X squared to the 1, which is X squared, X to the 5. Is that going to work? No. So then I'm going to try a 4. This would be X squared to the 2, which is X to the 4. And this is X to the 4, so they're going to cancel. So K is 4. What term is that then? 5, because K is almost 1 less than the term. What's 6C4? 15. And then we'd have X squared to the 2 over 2 over X to the 4. So we're going to get 15 X to the 4. 2 to the 4 is 16 over X to the 4. We know we're right because the X to the 4's cancel. What's 15 times 16? 240? Remember, they can ask for the term number as well. Two left. Okay, 22. In the expansion of the binomial 2a plus 1 over a, the constant term can be found using the general term. The list below shows possible values for n, k, x, and y. All right. To find the constant term, the correct values of n, k, x, and y are, well, let's figure it out first. So we're going to go 8c blank, 2a to the 8 minus blank, 1 over a to the blank. So I need these to cancel. It's going to be 4, because both of these are a. My blank is going to be 4. So what is my n? Because that comes first. N is 8. 8 is what reference number? 5. K is what? 4. And 4 is reference number 3. X is? Yep. X is 2a, which is reference number. And then y is a to the negative 1, because 1 over a is just a to the negative 1, which is 8. Okay, this is the last type of binomial that they throw at you. So given that a term in the expansion of ax minus y to the 6 is negative 252 xy to the 5, determine the numerical value of a. So we know this is x. We know this is y. We know this is n. Now they gave us the actual term this time. So we have to set it equal to that value. And that's what everyone forgets to do. So we get 6c blank ax to the 6 minus blank negative y to the blank equals negative 252 xy to the 5. What is our blank going to have to be? 5. Because you need y to the 5. It's going to stay negative. It's a negative 1. Don't take a wild guess. It's a bad decision. 6c5 is what? He's taking a wild guess based on the answer at the bottom. It's 6. Now, this is a to the 1. You're lucky. It's a to the 1, x to the 1. But what if it wasn't a to the 1? If it was a to the 2 or a to the 3? You have to remember to distribute it because you're going to have to take that answer at the end and square root it or cube root it or fourth root it. In this case, they were super nice. It's a to the 1. So if I forget to 1 root it, it ain't going to matter. But if it was a 2 or a 3 or 4 and you forget to distribute the 1 to it, can you see how it's going to get you the wrong answer? So don't forget that. And then we're going to have negative 1, because it's going to be 5 to the negative 1, which is negative 1. Y to the 5 equals negative 252 xy to the 5. Divide by xy to the 5. So that goes away on both of them. And so I'm left with negative 6a equals negative 252. Divide by negative 6. And a equals 42. Now remember, if that wasn't a squared or an a cubed or an a4, you'd have to take the fourth root of your answer. Do you think they'll have the answer without taking the fourth root of it? Absolutely. All right.